Welcome to Lesson 1 of Module 3 on the relational data model. I'm going to start with an important practical question that I want you to think about throughout this lesson. Why is the relational data model commercially dominant? Module 3 is a major change in the course. Module 2 was informational, providing background and context for other modules. Module 3 emphasizes concrete skills and knowledge about the relational data model. You will apply your knowledge and skills on practice and graded problems using a DBMS, either Oracle or MySQL. This lesson provides your initial background in the relational data model, so the learning objectives are modest. I want you to be able to identify components and sample tables using additional rows that you add. To become familiar discussing relational databases in several contexts, you should be able to list alternative terminology used for the basic concepts. Relational database systems were originally developed because of familiarity and simplicity. Because tables are used to communicate ideas in many fields, the terminology of tables, rows, and columns is familiar to most users. A relational database consists of a collection of tables. Each table has a heading or definition part and a body or content part. The heading part consists of the table name and column names. For example, a student table may have columns for student number, student address, city, state, zip, class, major, and cumulative grade point average. The body shows the rows of the table. Each row in a student table represents a student enrolled at a university. A student table for a major university may have, let's say, 30 to 50 columns and more than 30,000 rows, too many to view at one time. To understand a table, it is also useful to view some of its rows. A table listing or data sheet shows the column names in the first row and the body in the other rows. The sample student table contains 3 sample rows representing university students. To facilitate communication, the naming convention for column names uses a table abbreviation, STD, followed by a descriptive name. Because column names are often used without identifying the associated tables, the abbreviation supports easy table association. Mixed case in the name highlights the different parts of a column name. It is not enough to understand each table individually. To understand a relational database, connections or relationships among tables must also be understood. The rows in a table are usually related to rows in other tables. Matching or identical values indicate relationships between tables. So consider the sample enrollment table in which each row represents a student enrolled in an offering of a course. The values in the STD number column of the enrollment table match the STD number values in the sample student table. For example, the first and third rows of the enrollment table have the same STD number value, 123-45-6789, as the first row of the student table. Likewise, the values in the offer number column of the enrollment table match the offer number column in the offering table. This graphical depiction of matching values can clarify the concept of relationships among tables. In the table listings, the matching values are difficult to identify. This graphical depiction only works on small sample tables as the arrows cross and become difficult to follow with more rows. In the graphical depiction, you should see that the first student row, 123-45-6789, is related to the first and third enrollment rows. Likewise, the first offering row, 1234, matches to the first 2 enrollment rows. The concept of matching values is crucial in relational databases. As you will see, relational databases typically contain many tables. Even a modest-sized database can have 10 to 15 tables. Large databases can have hundreds of tables. To extract meaningful information, it is often necessary to combine multiple tables using matching values. For example, by matching on student.studentNumber and enrollment.studentNumber, you could combine the student and enrollment tables. Similarly, by matching on enrollment.offernumber and offering.offernumber, you could combine the enrollment and offering tables. As you will see in Module 4, the operation of combining tables on matching values is known as a join. Understanding the connections between tables, or columns on which tables can be combined, is crucial for extracting useful information. You should be aware that other terminology is used besides table, row, and column. The divergence in terminology is due to the different groups that use databases. The table-oriented terminology originally appealed to end users. The set-oriented terminology appeals to academic researchers. And the record-oriented terminology really was originally appealed to information systems professionals. In practice, these terms may be mixed, even more confusing. For example, in the same sentence, you might hear both tables and fields. You should expect to see a mix of terminology in your career. Let's wrap up this lesson, giving you an initial background on the relational data model. Relational databases have been the dominant commercial standard in the database industry for more than 30 years. The relational data model is commercially dominant for several reasons. The idea of tables to organize data is simple and familiar. The relational data model has strong theoretical foundation from academic and commercial research. And many commercial, university, and open source products have implemented the relational model over more than 40 years. In addition, there's an important commercial standard, the structured query language, SQL, that has evolved over 30 years. I encourage you to use small sample tables to solidify your understanding of the relational model. You should try adding your own sample rows to the table shown in the notes and identify the components, especially matching values among rows in different tables.